Hey everyone, so today what we're going to do is look at how to solve for reaction forces. Now primarily when we're solving for reaction forces, we're talking about one of two things. We're either talking about a pin, which is represented with a triangle, and the triangle is sitting on a base. And remember, a pin can have two forces. It has both a vertical force and a horizontal force. Or we're going to talk about a roller. A roller is represented with a circle and it sits on a base. Now, just like a roller skate, it can only apply a force perpendicular to the surface it's on. So here, our surface is horizontal and the force it can create is vertical. Now, it doesn't have to be vertical. A roller can also sit on a wall surface. In that case, it creates a force that's horizontal. So vertical surface, horizontal force. All right, so those are our two types of reaction forces that we're going to be using primarily. Now, when we're solving for reaction forces, we're going to be using our three laws of statics, and you want to make sure you have these in your notes. So let's say the sum of the moments around any point is 0. The sum of the forces in the x direction is 0. And the sum of the forces in the y direction is also 0. These are our three rules for statics. Make sure you have them in your notes. Get used to using them. So let's look at how we're actually going to do this. So let's say we have a structure here. We'll make this a relatively simple structural, just a triangle. We'll put a pin on one side and a roller on the other side. We're going to label these points. So point A, point B, and point C. And let's go ahead and put a downward force on B of 100 newtons. We're also going to need some dimensions. So let's go ahead and say from here to there is 5 meters, and from B to C is 3 meters. Now the first thing we want to do is replace our supports with the reaction forces they create. So this is at A, so I'm going to call it my reaction force at A in the y direction. And I'm going to call this my reaction force at A in the x direction. Now you may wonder why I did up and right and not down or left or anything like that. And honestly, there's no reason other than up is positive and right is positive, and it's easier to start out assuming everything is positive numbers and then later change it to negative. If you start out assuming everything's negative, it's just one more complexity to deal with. So this was our pin. We had two reaction forces to replace it. This is our roller. So we're going to have a reaction force at C in the y direction, and that's because our roller was on a horizontal surface, so it creates a vertical reaction force. Now we're going to use our three rules. So we're going to take our sum of the moments, and we have to pick a point to take our moments around. I like to take the moments around wherever the pin is. In general, that's a good rule. So I'm going to say the sum of the moments around A is 0. Now let's look at the moments around A. So this force, the reaction at A in the y direction, does not create a moment, because remember, a moment is a force times a distance. There's no distance from RAY and point A. It goes through point A. So that distance would be 0, so the moment would be 0. So this creates no moment. RAX is the same deal. It goes through point A, so it also doesn't create a moment. However, we have two forces that do create moments. We have this 100 Newton downward force, and we have RCY, which is, of course, our reaction force at C. And again, I drew it up just because up is a positive direction. So let's go ahead and look at these moments around A. So moment is a force times a distance. We'll start with the 100 Newton force, and its distance is 5 meters. Now notice it's going to make things rotate clockwise. Clockwise means that this is a negative moment. We also have reaction force at C in the y direction. So plus our force times our distance. And this was 5 meters, that was 3 meters, so times 8 meters. And we know these equal 0. So this is negative. I'm going to move to the other side. So 500 equals RCY times 8 meters. So if I want to find what RCY is, I'll take 500 and divide it by 8. And I find that RCY is 62.5. All right, and this is going to be in newtons since it's a force. Now, since I know that this is positive, I guess we would say, since this is positive 62.5, what that tells me is that my arrow was going the right direction. If my arrow was pointing up, but the force was actually going down, I would get a negative number here. But since my arrow was pointing up and the number came out positive, that tells me my arrow is going the right way. So this is correct. Next, I'm going to take my sum of forces in the x direction. In this case, my only force in the x direction is RAX. So RAX. And I know my sum of forces in the x direction equals 0, which is also equal to RAX. So RAX has to equal 0. So that makes sense. So let's go ahead and just write these in here. RCY, 62.5, and 0. All right. Next, we'll take our sum of forces. I'm going to erase this and get it out of the way. So our sum of forces in the y direction. Now notice I've used my 3 laws, right? Sum of moments equals 0. Sum of forces in the x direction equals 0, and sum of forces in the y direction equals 0. So what are my forces in the y direction? I have 3 of them. I have RAY, which I have pointing up. I have 100 newtons, which I have pointing down. I have RCY. Now, just because we found RCY doesn't mean that we can ignore it. So what does this equal? Well, RAY is pointing up, so I'll make it positive, RAY. My 100 newtons is pointing down, so I'll make it negative, minus 100. And my RCY is pointing up, so I'll make it positive, RCY. Now, we know RCY, because right now, this equation has 2 unknowns. So if I started with sum of forces in the y direction, I would hit this point and I would get stuck. But that's okay. What that tells me is I just need to come back to it. And after I found my sum of moments equaling 0, then I can come back to it and say, oh, RCY, I actually know how much that is now. It is 62.5. And things are better. All right. So I'm going to go ahead, just do a little bit of algebra. 0 equals RAY minus 37.5, and I just took negative 162.5 and add them together. I'll move my negative 37.5 to the other side, and I'll find 37.5 equals RAY. And now we've solved for RAY, and I can go ahead and write it on here. All right, so that's our first example. We'll have a video with another example.